this video, we're going to look at the solution to a problem. And to do this, we've got some data we're going to look at. And this data has to do with the period in seconds it takes for a pendulum to swing related to the length of the pendulum. So first thing I'm going to do is I'm going to copy this data and I am going to drop it into my desmos file. And I'm going to take a look at this data. Now, if we look at this data, it doesn't look linear. It looks more quadratic, or it looks like the right half of a parabola. So if you recall, the standard form of a parabola is y equals ax squared plus bx plus c. But since we're doing a regression, we're going to use y1 because we're using the data that's been stored in the y1 side of this column. We're going to regress it against, so instead of using the equal sign, use the tilde, which is to the left of the number 1 on the keyboard. And your coefficients are going to be the same as they are in standard form, so ax1 squared, because again, we need the subscript of 1 on the x's because we're using the data in the x column, plus bx1 plus c. Now, if we do that, we're going to get a regression model that fits our data. And if I zoom out just a little bit, you can see that it creates a full parabola. However, this parabola only makes sense for time greater than 0. So when I put in my equation, I'm going to call it f of x. And remember, x in this case is our time measured in seconds, equals, and I'm going to grab these coefficients that Desmos figured out for me. I'm going to round to 3 decimal places, so 9.782. Make sure you round correctly. We've got a 9 after the 1, so I'm going to round that to 2. X squared plus b is negative 0.00. I think I'm going to use more than 3 decimal places, actually. I think we're going to have more accuracy since we go out to so many places. I'm going to go back and include all of my decimal places here. Excuse me. All right, and then I'm going to put x, and then finally my c is 0.00303571. And you can see that that equation fits my model pretty well. If I turn off the regression model and I turn on the one that I've used, I've got the same thing. And we are going to just restrict the domain so that x is greater than or equal to 0. And then we will only see, I need to use the French brackets for this. And then we are only going to see the right-hand side of that. So I've got my regression equation, and now if I want to make any estimates, since I've written this in function form, I can put in different values for x. So if we want to predict the length of the pendulum, if the period is 3 seconds, we can do f of 3 and get an approximation there, which is 88.022. So if we wanted to look at that particular value, we could graph that as well. We could graph 3 comma f of 3 to see where that point is, and we can see that also lies on my parabola. So if a pendulum has a period of 3 seconds, it's going to be approximately 88.022 inches long.